Hi guys, welcome to 3.4, Solving Inequalities Using Addition and Subtraction. If you need to pause, if you don't have your book in front of you, would you pause the video and go get it? Because we're going to use the book as well as these notes as we go through. And I need you to have it open to page 140. That's where 3.4 starts. We're talking about inequalities, and I don't know how much y'all know about inequalities, but we're going to be solving inequalities just like we did equations. So you can see on page 140, you can see the definition of the word inequality, and you can copy that. Just like an equation was a statement and a math sentence that was formed by placing an equal sign in between two expressions. This is two expressions, right? Two expressions with an inequality symbol between them. There are four inequality symbols, four of them. They are greater than, that looks like that, greater than or equal to, which is the greater than symbol with a line underneath it, less than or equal to. Greater than and greater than or equal to are two different things. If I were to ask you in class if everybody that was greater than 12 years old stand up, I would get those people that have had their 13th birthday, but the 12-year-olds would be sitting down. If I said everybody whose age is greater than or equal to 12, everybody would stand up because you would either be greater than 12 years old or you would be 12 years old. So those are four different inequality symbols, and we're going to use one of those every time we create an inequality. The other thing that's a little bit different about inequalities than equations, when you look at this, this says k is less than or equal to -4. That's the same thing as saying -4 is bigger than or equal to k. We can say the same inequality in two ways. Another example of that might be I can walk up to you and I can say, I am older than you. So Ms. Leininger is older than a student, or I could say the student is younger than Ms. Leininger. So the inequality symbols are going different ways depending on the way the inequality is set up. You can see the solution of an inequality, that's on page 140 as well, and kind of like when we solved the equation, these are the numbers that make your statement true, that make your inequality statement true. When we're talking about inequalities and we're solving inequalities, we graph the solution as well as find it. And we do that because when we're solving an equation, if I had x plus 3 equals 10, there's only one answer. X has to be 7. We know it's 7. There are no other answers. You don't need to do a number line and graph that point of 7 because I know that the answer is 7, and I know where it is on the number line. However, when we graph an inequality, or when we solve an inequality, there are many solutions, many numbers that make our statement true. So we graph them to show all of the possibilities for our answers. So we're gonna start on some of these, and when we add and subtract to solve inequalities, we use the same properties of equality that we did when we were solving equations. We have to do it to both sides of the inequality. We use the inverse operation, all the same stuff you guys are used to. But before we actually go on and start solving some, I want you to look on page 40 at the graphs in the middle of the page of the three inequalities they have there. They have x is less than 3, which says, whoa, that is crazy. What is that? Okay, I'm back. My craziness, I think I've got it. I did erase what I'd written, but you guys have written it down already. So I was talking about the the four graphs on page 140 that show the four different inequality symbols graphed. The first one we were looking at was, I'm going to move this. Let's see. Bear with me. All right. The first one we were looking at in the middle of the page is x is less than 3. That says I want, in English words, all numbers less than 3. Well, you can't list all numbers less than 3 because there's an infinite amount. You'd spend your whole life doing it. But you can graph it. You can show me on a number line all the numbers that are less than 3. So here's my sketch of a graph, and you can look in your book. Here's 3, so I'm going to circle that. I call that my target number. I want you to show me on the graph all numbers that are less than 3. Those are to the left. They are going this way. So there's your graph of all numbers that are less than 3. The second one, all numbers that are greater than 2. So as you might expect, it's going to look similar. We're going to start at our target number, which is 2, and all of the numbers that are bigger than 2 are headed this way to positive infinity. The last two examples are all the numbers z that are less than or equal to 4. So the way that we show that equal is like this. Whoops, there's 4. Here's my target number. I draw a circle around it, and because there is this line underneath it, and I want to include 4 as a number that will make my statement true, I circle it in, I color it in. So notice on these first two examples, the circle is open. That means it does not include the point 3. 3 is not less than 3, so we can't color it in. But in this case, it says z is less than or equal to 4. So yeah, 4 works. And we want all the numbers that are smaller or equal to, so again, we shade it in this way. And you can look at that fourth example, all the numbers that are greater than or equal to 2, and they graph it. So when we start solving our inequalities, we are going to solve it, but we're also going to graph it. So that's what I'm going to ask you guys to do as well. Here's example number 1. Box and rewrite. Nothing new there. Ask yourself, is the variable alone? No, he's not alone. He's got this 12 attached by addition. So we're going to subtract 12 from both sides. Now the k is alone. We bring down our inequality symbol, less than or equal to, and it's minus 16. I would be finished if I was solving an equation, but I have an inequality, so I'm going to put my target number right here. I'm going to put a number to the right, which would be negative 15, and a number to the left, which would be negative 17. I am going to circle my target number. Now I go back up here and I say, is there a line underneath it? Yes. So my circle is going to be colored in because I want all the numbers that are less than or equal to negative 16. So negative 16 makes it true. And now I have to figure out which way am I going to graph. I want the numbers that are smaller than negative 16. We're going this way. Those are the numbers getting smaller. So there's the two parts to your solving. You've got the answer and you've got the graph. Let's do number 2. Box it up. Rewrite. Add 36 to both sides. This is straightforward. Today we're just dealing with adding and subtraction. That's 43. 36 plus 7. I'm good to go, except I need a graph. My target number is 43. On the right is 44. On the left is 42. This is a normal number line going up to the right and down to the left. Here's my target number. I ask myself, does it have a line underneath it? Is 43 part of my solution? Yes, it is. So I'm going to color it in. And again, I now need to shade one part of the graph or the other, and this tells me, show me all of the numbers that are bigger than or equal to 43. So that's going this way. Let's run through a couple more. Box it up. This one we have to collect our like terms. I see a 7 and a 10. I'm going to write it x plus 17 less than negative 2. Subtract 17 from both sides. We end up with x less than negative 19. So I'm going to draw my number line. My target number is negative 19. In the negative numbers, we've got to go this way, positive 1, which would be negative 18. And in the negative direction, this would be negative 20. You need to put 3 numbers on your graph. You don't have to put any more. I'm going to circle my target number. There is no line underneath. So negative 19 is not going to be a part of my solution, so I leave his circle open. And now I just have to decide how am I going to shade it. I want all of the numbers that are smaller than negative 19. That's going this way. And that's your graph. Let's do number 4. Negative 19 plus x greater than negative 6. Add 19 to both sides. X is greater than 13. Again, I've got to sketch a graph. I'm at my target number is 13, going up by 1, going down by 1. Circle the target. Does not have a line underneath his inequality symbol. I want all the numbers that are larger than 13, but not including 13. So I don't fill in the circle, and I have my arrow going that way. Okay. So you'll notice 5 and 6 are a little bit different because the variable is on the right. All of the other ones that we've looked at, the variable's on the left. I think the easiest way to work these is to move this guy, x plus 8, and switch him and put negative 8 on the right. When you do that, you have to flip this sign. So it goes this way now. This is just like when I said earlier in the video, if I'm saying that I'm older than you, I can also say you're younger than me, but that's a different inequality sign. So once you've done that, now we will just box it up. Well, I'll box up what's up here. I rewrote it. Subtract 8 from both sides, and I get x less than negative 16. And I've got to sketch a quick graph. So my target number is negative 16. Here's negative 15. And here's negative 17. I don't have a line underneath it, so I'm going to leave my circle open. And I want all the numbers that are less than negative 16. It's going that way. Number 6, let's pick it up. The x minus 10, move him over here. Move the negative 1 over here. And flip the sign. You can do that on the rewrite step. Add 10 to both sides, and we get x greater than 9. And again, sketching a quick graph, 9 is my target number, 10 is bigger, 8 is smaller. Open circle, because I do not have a line underneath the 9, and I want all the numbers that are larger than 9. If you look back on all the problems that we worked, and these two right here, as long as your variable is on this side, on the left-hand side, what you shade, the direction you shade will be the same direction that the inequality is going. This guy's pointing this way, I'm shading this way. This guy's pointing this way, I'm shading that way. And if you go back and look at the problems that we worked, all of these the same, because the variable's on the left. This is pointing to the left, so that's the way my arrow is going. Every single one of these. If your variable, if we had left that variable on the right-hand side, then you would have had a shading that goes opposite. So I think that's why I think it's easier to pick it up and move it. Okay, let's just run through a couple of these. We're going to write an inequality. A boat must be at least 20 feet long, 24 feet long. Can it be longer than 24? Sure. Can it be 24? Yes. So we would write it x greater than or equal to 24. He can be 24 feet and he can be longer. A golfer's longest drive, that's as far as he's ever gone, is 325. So his drive, they could be less than that or equal to that, but he doesn't have anything greater than 325. That's what this inequality says. The maximum speed of the race car is 180. So the speed can be less than 180 and it can be 180, but it can't be, you can't go faster than that. The lowest attendance for a concert has been 580. So you need to ask yourself, could it have been 700 or could it have been 500? Which way is your inequality going? So the attendance has been greater than or equal to 580. It says the very smallest crowd they ever got was 580. Here's one like you might see at Six Flags for a ride. Your height must reach or exceed. There's your inequality symbol. All of these that I've underlined are the English words that are going to get you to an inequality symbol. Your height must reach or exceed. So height must be greater than or equal to 60 inches. So that's the end of the notes, I think. Let me see if there's something else down here. Oh, yeah, we've got to plug this in. So tell whether this given number, these numbers right here, are they solutions of this particular inequality, which means when you plug negative 8 in, do you get a true statement? So negative 8 greater than negative 9. Is that true? Is negative 8 bigger than negative 9? Yes, it is. 1/2. Is that greater than negative 9? Yes, it is. And 0, is that greater than negative 9? So all of these, we're asking ourselves, does it make a true statement when you plug it in? And yes, it makes a true statement here, too. Okay, thanks for watching. I'll see you in class.